Hi guys. So we are doing Module 6 Grade 6, Module 1, Lesson 3, Equivalent Ratios, which I think is a really fun one. So to start with, to warm us up, a little review from last lesson. Exercise 1 says, write a one-sentence story problem about a ratio. So it's up to you what the ratio is. I'm going to choose, actually write the ratio in two different forms. I'm going to do 3 to 1. That's going to be my ratio. And I'm going to try and think what kind of scenario could it be that is 3 to 1. I want you to come up with something different. Mine's going to be, it was really rainy today and really cloudy here in Maltby. So for every 3 rainy days we have in Washington, there is 1 sunny day. I don't think that's true, but it kind of feels like it. So I have my one-sentence story problem. For every 3 rainy days, there's 1 sunny day. I wrote it one way. How else could I write this? 3, 2, 1. There we go. Pause and write your story problem. All right, we're looking at the second part now. So it says, Exercise 2. Shani and Mel are using a ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. Draw a tape diagram to represent this ratio. So here's what I'm going to do. I'm going to show Shani here. And then I'm going to show, who's Mel? Yes, Mel here. So Shani to Mel, 7 to 3. But we're going to do this with a tape diagram. So here's how this is going to look. I'm going to do a tape diagram with units. That's going to be 1 unit. So here's 1. Shani has 7, 2. Actually, I'm going to just do a really long one and cut it up. 3, 4, 5, 6, 7. Let me check. 1, 2, 3, 4, 5, 6, 7. There we go. So here's my 7 to Mel's 3. I'm going to try and make them the same size as Shani's. There you go. 7 to 3. Now, the second part of this, it's on the back side, which is kind of a bummer. But it says, Exercise 3. Oh, I thought we had to problem solve with that. I guess not. There's Shani's 7 to 3. Although, let's play around with this for just a second because I think it's going to help on the second one. So we have ribbon. Shani's is obviously longer than Mel's, but we don't actually know the length of Shani's ribbon. So let me say that each unit is maybe 1 inch. So I'm going to write this really lightly because I'm going to be erasing it, but let's say that's 1 inch. That means this would be 1 inch, 1 inch, 1 inch, 1 inch, 1 inch, 1 inch. How many total inches is Shani's ribbon? Well, right now it's 7 inches to Mel's. Oh, if this is 1 inch, how many inches does Mel have? 1 inch, 1 inch, 1 inch. Mel's 3 inches. But did it say anywhere that each unit is 1 inch? No. So I'm going to erase those again. We could make this anything. What if instead of 1 inch, what if each unit was actually 2 meters? So remember, a meter is about that big. 2 meters. It's going to be a long piece of ribbon. Each unit is 2 meters. Then Mel's also has to be 2 meters for each unit. Now how long is Shani's ribbon? 2 meters, 2, so it'd be 2, 4, 6, 8, 10, 12, 14 meters long. How long would Mel's ribbon be then? 2, 4, 6 meters long. Okay, but did it say anywhere that the unit is worth 2 meters? No. So I'm going to erase these again, and let's just do one last one. What if every unit was actually worth 3 centimeters? So it's pretty small. 3 centimeters, that means that's 3 3, 3, 3, 3, 3, 3, 3, and 3. Can you take a second to figure out what Shani's ribbon would be in centimeters and what Mel's ribbon would be in centimeters? Well, up here, 3, 6, 9, 12, 15, 18, 21 centimeters for Shani. And that means 3, 6, 9 centimeters for Mel. But over here, you'll notice I didn't actually write ratios. I was just kind of making a table to show this. If I was to write the ratios, this one would be 7 to 3. 14 meters to 6 meters would be 14 to 6. And 21 to 9, 21 to 9. In ratios, we don't have a unit. Do you notice anything about the ratios that we wrote here? There's something that we call equivalent, because you'll notice that picture never changed. The length of the ribbon here was always shown as the same. I never added more pieces. All that changed was the unit. So all of these are equivalent ratios. So what do you notice about this? Well, something I'm noticing is that to go from that 7 to 14, it just doubled times 2. What happened to Mel's? Did it also double? Times 2. It did. Let me rewrite down here because we had the 7 to the 3. What happened here? Well, 7, 14, 21. That tripled. Same with over here. This tripled. 3 times 3 was 9. So you can find equivalent ratios as long as you're multiplying the ratio by the same factor. So for example, I already did times 2 times 3. If I took this and I multiplied both of these times 5, 7 times 5 would be 35. 3 times 5, 15. 35 fifteenths would be an equivalent ratio. All right, this is going to help us in the next part. So now on the back side, we have another question. Exercise 3 says Mason and Lainey ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Lainey ran, just underlining that to make it stick out, was 2 to 3. If Mason ran 4 miles, how far did Lainey run? Draw a tape diagram to demonstrate how you found the answer. So again, we have Mason and Lainey. So I have Mason and Lainey, setting it just like I did before. And looking at what we know, it shows that Mason, for every 2 laps Mason did, Lainey did 3. So I'm going to show that here. Mason, for every 2 Mason did, Lainey did 3. Oops. Make sure they stay about the same. So if I end there, that would be my 2 units. I'm going to keep going a little bit. So here's my 2, and I added a 3rd. My drawing got a little wonky, but you get the point. Okay, but that's not all they want to know. We did our 2 to 3 ratio. But now it's saying Mason ran 4 miles. So whatever this equals, this was 4 miles total. Could we use that 4 miles to figure out what each of these units would be worth? It has 2 units, and I know 4 divided into 2 parts means this would be 2 miles, and this would be 2 miles. Does that help me figure out how long Lainey ran? Yeah, because if each unit is 2 miles, that means this is 2, this is 2, this is 2. How far did Lainey run? Lainey ran 6 miles. 2, 4, 6. See how that's kind of helpful? Let's look at B. Same idea. Now it's saying if Lainey ran 930 meters, how far did Mason run? Draw a tape diagram to determine how you found the answer. So still we're working at the same ratio. It's still 2 to 3. So I'm going to rewrite it. If I'm ever going too fast, don't forget to pause. Here's Mason and Lainey. Again, Mason had these 2 units. Lainey had 3 units. Like that. But now they're saying Lainey ran 930 meters. So these 3 pieces together would be 930 meters. Could you figure out what would be in one section? Why don't you pause, see if you can figure that out. All right, if you got stuck, in my head I'm kind of thinking 930 divided into those 3 parts. If I split 9 into 3 parts, I'd have 3 in each part. If I split 3 into 3 parts, I'd have 1 in each part. And if I split 0 into 3 parts, I'd have 0 in each part. So if I have 310 plus 310 plus 310, that would be 930. If this is how each unit was for Lainey, what would it be for Mason? Well, all the units have to be the same. We're looking at ratios, so this should be 310, and this should be 310. So the question is, how far did Mason run? Can you write your answer here? Pause until you figure it out. All right, Mason, 310 plus 310. Mason ran 620 meters. There you go. What ratios can we say are equivalent to 2 to 3? So kind of thinking back to what I did here, 7 to 3 was equivalent to 14 to 6. 21 to 9 was equivalent. 35 to 15 was equivalent. So what equivalent ones? We just built a couple of them. What ratio is this showing up here? We had Mason first. Remember, Mason was the 2. So we had 4 to 6. So we know 4 to 6 would be equivalent. What does this one show? Oh, goodness. 620. Whoopsies, that's not what I wanted to write. 620 to 900. Oh, my goodness. 930. Those are also equivalent. All of these ratios are equivalent from one another. All right, exercise 4. Josie took a long multiple choice end of year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. So we're looking at incorrect versus correct. Let's say incorrect to correct. So what was the ratio? Could you draw it? Pause if you need. Incorrect, she got 2. So if she got 2 questions wrong, then how many would she have gotten right? 9. Let's see, how far do I need to go? So I have 1, 2, 3, 4, 5, 6. Oh, I'm not far enough. 7, 8, 9. Let me check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to 9. But then it's actually giving us some numbers. She didn't just get 2 wrong. It says, if Josie missed 8 questions, how many did she get correct? Can you figure that part out? If she missed 8 questions, so if this is 8, how many did she get correct? Pause to do your work. All right. If 8 were incorrect, that means each of these would be 4. 4 plus 4 is 8. If these are 4, then each one of these has to be 4. So she got 8 questions wrong. She got 4, 8, 12, 16, 20, 24, 28, 32, 36. I want to make sure I did that right. 9 times 4, 36. Ooh boy, this is a big one. 36. So the question is, how many did she get correct? She got 36 correct. It changed. Now, what if Josie missed 20 questions? How many did she get correct? The ratio didn't change, so let's rewrite the incorrect to the correct. Incorrect, there should be 2. Correct, it was 2 to 9, so make this go. Make sure you get 9 pieces. 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Oopsies. 9. So again, it's saying she got 20 incorrect. She missed 20. Can you figure out how many she would have gotten correct then? Pause it a second. So again, if this is 20, each one of these would be 10. If each one of these is 10, each one of these units is 10. How many questions did she get correct? 10, 20, 30, 40, 50, 60, 70, 80, 90 questions correct. All right, I think this is the last one. So now, looking at the questions we just solved, what ratios would be the same as 2 to 9? What ratio is this one showing up here? Because this wasn't 2 total. What was it? 8 to 36. 8 to 36. How about in B? 20 to, how many here? 90. These would be equivalent ratios. All right. Oh, there's the backside. Can you come up with another possible ratio for the number Josie got incorrect to the number she got correct? And we have to make sure it's saying equivalent. So it was 2 to 9. 2 to 9. How could you change this to make it stay equivalent? Truly, you could do almost anything. I'm going to do times 2. So if she got 4 questions incorrect, how many correct would she have gotten? 18. I want you to come up with one. And then how did you find the numbers? Well, I multiplied each number in the ratio by the same number. That is important. It has to be the same. You can't do a 2 and a 7. Describe how to create equivalent ratios. How did we do that? Take the ratio and multiply each number by the same factor. Basically said that same thing up here. I think they probably wanted me to say I multiplied each number in the ratio by, instead of the same number, by 2. That's probably what they wanted me to do. All right, I believe that is the end of the lesson. So again, read the summary. So it says 2 ratios, A to B and C to D are equivalent ratios if there is a non-zero number, C, such that C equals C times A and D equals C times B. For example, 2 ratios are equivalent if they have the same values that are equal. So what it's saying, like if I made A to B to be, let's make it really simple, 1 to 2, and C and D. So if I have 1 to 2, if I take the same thing, so we see how they're multiplied by C here. So if I took this and did like times 5, 1 times 5 would be 5, 2 times 5 is 10. So if these were my C and D, 5 and 10, these two ratios are equivalent if I multiplied them by the same factor. And it says ratios are equivalent if there is a non-zero number that can be multiplied by both quantities in one ratio to equal the corresponding quantities in the second ratio. So basically what I'm showing here. All right, work on your problem set. If you have questions, they should be available soon, but ask each other, rely on each other, and try your best. If you need extra space, make sure you get lined paper. Good job, everyone.